So the question today is, what are layer lines and why do they matter? The first thing to know is that this video mainly applies to FDM or fused deposition modeling 3D printers. There are two main kinds of 3D printers in the hobby space right now, which are FDM and resin. I think there's also a third version that's coming into perspective called SLS or selective laser sintering, but this is newer from what I know and very expensive, so I don't think it's considered mainstream like these other versions. Anyway, I have no personal experience with resin 3D printing, and additionally I had a hard time finding any specific info about resin's layer adhesion properties, especially when talking about strength. But we'll talk about that more in a little bit. So even if layer lines do affect resin prints, I think that it is much more of a major factor on FDM. 3D printers work by building objects by layers, kind of like bricks, except the bricks are big, long, single strips of material. The objective is to get these layers to at least somewhat fuse together to make the created object actually solid. For resin and SLS, from what I know at least, these layers fuse more efficiently, and thus make the objects stronger and the layer lines less of a structural issue. I'm not 100% sure on that as a fact, so don't take that statement as one. But FDM seems to typically have a harder time creating the bond. So most times with most plastic types, they are never truly fused together. Typically they are adhered and stuck together, but they are not truly solid. At least not like the ideal scenario for these machines and processes would probably have them be. There are some exceptions to this, but majority of plastics have issues with their fusing when being used in functional scenarios. The layers are simply laid on top of each other, and when using the same material throughout the print, it can form a somewhat chemical or lighter physical bond comparatively. Otherwise, you're just hoping that the flowed material can sort of glue itself to the other materials in its tacky, viscous flow state. Sometimes materials just don't like to bond to each other in multi-material prints. I don't think people actually do multi-material very often unless they're using one material for supports and the other for the main body. I will warn you that I'm not a scientist or anything, and I haven't extensively studied the exact way that this process works, but it is a generally good idea of what's happening. Now, because of the manufacturing method, they first of all typically leave little ridges or bumps vertically on your prints. These bumps have been getting less and less noticeable with the development of the technology and the software associated with 3D printing. Typically, even when you can't see the bumps though, if you scratch your nail over them or have friction between the two parts, you can still hear them. Okay, this is a print that turned out a little worse than usual, so it has some layer lines. I don't know if you can see them on this camera, but it's a good example. And the prints are usually weaker along the vertical axis because of these semi-solid bonds. So other than the visual aspect, this is where thinking about your layer lines really matters. This degraded strength can be a big issue for a lot of functional 3D prints. One of the theoretically worst objects to 3D print is a hammer. First of all, it's highly likely that it's not going to be as effective as a normally manufactured hammer, if that is what you are trying to replicate or create it for. However, people have created other 3D printed hammers for lighter striking applications. But if we were trying to make a hammer to actually pound nails, the handle would typically be the main issue. With a longer handle and a weighted head, typically you can get more force with a properly manufactured hammer due to the physics and all that sort of stuff. But even a standard length handle for a hammer, if I'm not mistaken, can't actually fit on a 3D printing bed sideways. At least not most average 3D printers. Printing the hammer handle sideways would be the optimal orientation for the strength because the layer lines are then in line with the action of the hammer. If you look at real-life tools with wooden handles, you will often see this same theory in play with the grain of the wood. Actually, after trying to double check that I was actually explaining this correct, a lot of tool companies don't care about the grain direction as long as they can get another tool out of their mass manufacturing process. That is, unless they are a more reputable brand with integrity, but that oftentimes leads to more expensive products, but that's getting off track. Despite this fact, it does still matter in the long-term health of a tool. The grain should match the hammer and claw direction to maintain the integrity of the handle. So if it helps you, you can think of the layer lines as the wood grain. Now, many printers have a larger vertical build area than horizontal. So you could create the handle pointed straight up. Now there are some other issues with printing tall, skinnier objects, but additionally, the layer line separations are now in line with the action of the hammer. So if you can use the hammer that was printed sideways, this one would probably break on the first 10 uses, if not the very first. There are many other objects and designs where layer lines come into play, but this one is one of the easiest examples. A great resource that talks about how to combat the weaknesses of layer lines is a channel called Slant 3D. They make great videos about different mechanical design concepts and overall object design concepts in 3D printing as well, due to them wanting you to use their service, which teaching these concepts supports. So that's all I have to say about the subject of layer lines for now. If you found this video informative, please leave a like. If I made a mistake, let me know in the comments, but don't be a prick about it. And don't correct me on semantics unless it's an actually important distinction. I try to cover myself as much as possible, trying not to say anything as a fact when I didn't know it as a fact. I don't make a regular income, so please consider using one of the affiliate links in the description leading to some good 3D printing stuff that I personally use. This adds no cost to you and helps me out a bit. Don't forget to remove the honey extension if you use the links and have it, since they steal these commissions from people like me. This channel is normally a 3D printing and music related channel, talking about 3D printers and concepts around them, as well as talking about guitar, drums, and bass guitar gear, and sometimes concepts around those as well. Additionally, I just do whatever I want sometimes, so there's that too. If any of that sounds good, please consider subscribing. That's all I have to say for now, so to say, bye-bye.